board on this computer. Here we go. So this is meteorological instrumentation, and it's Friday, March 1st. Hey, I forgot to ask.
March?
Yeah, no, I mean May. This is May 1st.
I mean, it feels like March like this year.
It feels like March. But I wanted to ask you, and I should have put this in a poll. Did anybody get a May basket today? No? Do you know what those are? Have you ever done those?
For May Day?
Yeah.
That was from Fred on
What?
YouTube. On YouTube, Fred. Do you remember Fred?
Yeah, that's
That
me.
really annoying guy. No, the really annoying kid guy. Does anybody know what I'm talking about? Do you remember Fred? He was on iCarly. He came out and was like Mayday type of deal. That's the only time I heard of it.
Well, it's kind of
too old for this class?
It's kind of
You're talking about Freddie?
No, not Freddie from iCarly. The weird YouTuber guy. Fred, has a high voice.
I know exactly who you're talking about.
Thank you, Matt. Thank you.
You got to show me this guy.
I wish I memorized YouTubers because I really don't.
You've got to show me this guy sometime. Okay?
I'll bring it up.
Oh, just send it to me. Send it to me and I'll take a look at it.
Okay, but I also have a radar question. I can ask you later.
Yep. Well, at the end of this, we'll talk a little bit about your questions. So what we're going to do today is kind of go through, let's see, we are going to go through assignment number 17. Also, we'll talk about lab. Let's talk about lab first. Fred. Oh, yeah, that's Fred. Okay. With the R backwards. I wonder how he did that. Okay, so let's see. Do you have any questions about lab this week?
Those, I got your email back. But all of my questions are about lab, but I didn't have a Zoom. I didn't know how to make like a Zoom with Donald. He didn't have office hour Zooms. So I just thought I'd stop into yours.
Oh, okay. Yeah, I did have a Zoom office hours, but I don't know. I had to leave at 11:15. Actually, I left at 11:10.
That's okay. That is okay.
I feel bad because I'm usually there the whole time, but this time I scooted out a little bit early because I got my hair cut.
Wow.
That's right. I should have remembered that.
So I'm sorry. I feel so guilty because nobody ever comes to see me except Juliana sometimes and Caitlin sometimes. But
I'll come see you on Monday.
That's okay. We can just talk after class.
Okay, we can talk after class. Great.
Awesome. Thank you.
Yeah, no problem. So let's see. Yeah, but do you have any questions, short questions? How lab this week, the HailPad? Yeah, okay, never mind. Let's move on to next week's lab. Next week's lab is normally what we do is we send up a radiosonde. And it's a really bummer if you guys can't do that this year. If you are a major, you will be doing that in thermo. We send it up in thermo on the last day. So you'll get to see it in thermo. Caitlin, do you remember that? Juliana, you remember that?
Yep.
Hey, is Catherine here? Hey, there she is. Okay, I have to scroll down to see you. And you remember that, right? Okay. So what we're going to do, I'm thinking of putting together just a little exercise. I would otherwise punt this lab because it's a lab that I really can't recreate. But I promised you 11 labs, and I feel like I should do that. And the reason I promised you 11 labs is because you get to drop one. And some of you may have been planning on dropping a lab. So if I don't have 11 labs, if you only have 10 and you already missed one, then you're in bad shape. And I really have to follow the syllabus as closely as possible. I know this is really a strange semester, but I am going to have one more lab. So do you have any suggestions what to do for lab?
The classic, put your name on the paper.
Take a picture of a cloud, send it in, write your name on it. 100%.
Well, I want it to be a learning exercise.
Explain the physical meteorology properties of the cloud.
Hey, what kind of clouds are there?
Oh, actually, Tony Granger? he won a picture of beer on that question, that very question. He was on a research project. After they got done flying, they went to a restaurant and a bar, and the trivia question was, what are the 10 types of clouds? And there was a group of cloud physicists sitting at the table. And so as a result, they won a pitcher of beer, which was like a coincidence. It was really amazing. But this lab, I'm thinking of doing is something that is very painful, but it's a great learning exercise. And no, does anybody know what a TTAA or a TTBB is? I think Juliana knows. Do you know what a TTA
Oh,
is?
I don't want to know. I don't want to know.
Oh, you don't know? Oh, come on, you send these
I
things
do.
out.
I do. I don't want to know, and I don't want to. No.
Okay.
Get it.
Anybody else know
Something's
what
up with your mic, Juliana.
Yeah, you overmodulated there.
It's like paranormal activity type of deal. It's going on.
Yep.
Oh, I don't know. Okay, let me go in.
Okay. Okay. Well, anyway, TTAAs and TTBBs are the coded information from the radiosonde launch. When they send up a radiosonde, this information has to be passed on worldwide, all around the world, to everyone who can use the upper air information. And so it's coded in this format. TTAAs are the mandatory reports, and TTBBs are significant reports. And I'm thinking of giving you TTAAs and TTBBs to decode. And it'll probably take about a half hour of your time, just one radiosonde. And I think it's important for atmospheric science majors to see where that comes from. For minors, you guys are free. I'll give it to you extra credit, okay? No, you got to do it. So I'm thinking of actually pulling some TTAAs and TTBBs and giving those to you, unless you have other suggestions besides putting your name on a piece of paper. It has to be a learning exercise. Would you rather write a paper on radiosondes? No. It's decoding. Decoding is kind of mindless.
So our term project in physical meteorology is taking pictures of stuff and then describing how it happens. So you can take a picture of a blue sky and describe why that is. That's a learning opportunity.
Yeah. You know, that actually morphed. I used to teach physical meteorology back in the day, about maybe 10 years or 15 years ago. And what we did, I actually started that. What we started doing was I would make, one day I was lecturing and I had, we were talking about cloud physics, and I had a picture of stratocumulus. And I said, everybody knows what kind of cloud this is. And I went around the room and nobody knew. I was just really dumbfounded. Nobody knew what a stratocumulus cloud looked like. So from that point on, every year for the next 10 years, I had my students create a cloud atlas. Did you hear about this? I don't know if you ever heard about it.
No.
But every year you would have to take 10, you'd have to take 10 pictures and submit 10 pictures of clouds. And the 10 genre, so nimbostratus, cumulonimbus, cumulus, stratus, altocumulus, altostratus, yada, yada, yada. So, and that's, that kind of morphed when Aaron took over the class. He continued that, but then he kind of morphed that into, you know, describe what's going on. And actually that's a good exercise also. But the cloud atlas was fun. Everybody was like trying to get the best clouds. So yeah, anyway. So, okay, if there are no other suggestions as far as what to do for lab, I'm going to have you decode TTAAs and TTBBs. And also I checked the lab grades, and I see that lab 7 grades and 8 grades are still not posted. And I've already addressed this 3 times. So I'm not sure what happened. I'm not sure what the problem is. So I will have to have a personal conversation and figure out what's going on, okay? But usually what I want is the grades to be done by the last week of class so that you know what to expect, what you need to get on the final exam. That's my expectations. So I already told that to the lab TA, the GTA, and he knows that he needs to get the grading done by next week. So, okay.
When will this final lab that we have next week, when will that one be due?
It'll probably be due on the final, on reading and review day, or do you want more time? Would reading and review day be okay, or no?
I think by midnight on reading and review day would be fine.
Yep, either that, or
That gives us a day and a half at least.
we could push it back to, and I'll probably end up grading this. How about final exam? Who would reading review be fair, or the final exam when it's done be fairer? How many people want final exam? How many people want reading review? Nobody's voting. Come on, guys.
Gotta do a poll, Fred.
What's that?
Poll. You gotta do a poll, Fred.
Okay, let me do a poll. Here we go. Okay. It takes time to create these, so I've got to actually go in and type it up. Okay. That's why I do this beforehand. Believe it or not, I actually prepare for class. So I know that really seems strange, but okay, here we go. I got to edit this. Let's see, I'm going to close this out here. And final lab. And then question is, what day should the final lab be due? Question mark. Okay. And should I put in just 2 suggestions or any day, many days? What do you think?
Just do 2. Just do Thursday at midnight, or Thursday at 11:59, or Friday at 11:59.
I'll do it this way.
That works
Friday midnight. These are your choices. And then final exam. And that would be Monday, right?
Mm-hmm.
Yeah.
Monday final exam.
So Friday midnight would be, it'd be Friday 11:59 p.m. So almost Saturday, or would it
Yeah,
be
almost Saturday. That's right. I give you all Friday. Yeah.
Yeah,
Okay.
let
Here
me
we go.
check.
Are you ready? Wait a second. I got to move this. This is not working. Hang on, guys. Move that. Oh, come on. I can't get down to the bottom where I can. It has save. No, come on. Dang it. Oh, I hate it when this happens. I'm trying to move.
Minimize the page, Fred. Like,
Save. There we go. Okay, great. Here we go. So let's see. Meeting information. Oh, wait a second. I'm going here and I'm doing a poll. Are you ready? Share results. No. Launch.
okay, got it. Okay, good.
Okay, final lab. Launch the polling. Vote. What was that?
Might have been my dog.
Oh, you have a dog?
I do have a dog.
What kind of dog?
He is a black lab.
Oh,
What's his name?
His name is Kip. He just turned 14 on Wednesday.
That's amazing.
Yes, he's an old puppy.
okay. Are you ready? Here are the results. And it looks like it is Monday. Is that okay?
Damn it.
Well, actually, you can turn it in on Friday if you want. You can get it done early.
I forgot my mic was on. I'm sorry.
Oh. You know what? Even though, we're doing this Zoom and stuff like this, I'm going to miss you guys. This has been a great class. You guys have been good. I don't know if you learned anything at all, but it's been fun. Oh, gosh. Oh, man. It's been a hell of a semester, from the coronavirus to throwing up in airplanes and everything else. It's just been a fun semester. Yeah, so
Wait, what was that?
Who threw up in your airplane?
I got sick in the airplane.
You did?
Yes.
Wait, when?
Oh, let's not talk about it. Okay, so that's that. Okay, so we know when you guys need to have this in. And I really, like I say, once again, I really don't want to do this. You don't want to do this, but I need to get a grade in for the lab. For people who have not done a lab, they would get a 0, and that would really suck. And I can't do that for those people. So we need to do this. And you will learn something from it. I mean, you'll learn that you never want to decode a TTAA or TTBB again. Oh, speaking of radiosondes, today actually is kind of radiosonde day. I don't know if you looked at the schedule. But did you see that? I don't know if you've heard this. I was watching the news this morning. I was watching Lydia, who was a former student here at UND. And she's on channel 6, channel 8 at early morning. She's the morning meteorologist. But they found a radiosonde in Leonard, North Dakota. Did you guys hear about that or see that?
From Bismarck?
Yeah. Do you mind if I pull that up real quick?
Yeah.
Actually, I'm going to pull up a map. She had a picture of the radiosonde, and I didn't have enough time to get an email off to her and ask her to send me the picture of the radiosonde. But let me do it this way. I'll get out of that. Let me go here. Can you see this? Let's see. What are you looking at now? Yep, actually, you can see that. I'm going to go to maps here. Let's see. Maps.google. Oh, I can't spell, can I? Maps, there it is. Okay, so they launched the balloon, and I'm going to share that. Yep, that's being shared. We're zooming out. Woo, there we go. And then let's see, where's Bismarck? There's Jamestown. Here's Bismarck. We're going to go ahead and put a point at the airport. So we are going to measure the distance from there to, tell me when you see Leonard. Let's see. Dawson, I feel like I'm driving 94, but really fast. Here we go. Let's see. There's Jamestown. We're getting closer. Here is Valley City, Tower City. Have you ever stopped in Tower City? Oh, they've got the best pie. You got to stop there, really. That's like the pie stop. And then Castleton. Go south of Castleton. And there's Leonard. So measure the distance to here. 166 miles the radiosonde traveled. And that radiosonde was launched on March, I think it was March 31st. And he found it, it's a farmer who found it in his field. So that gives you an idea how far downwind these radiosondes travel. They can travel, you know, that's just one example, 166 miles. Juliana, you've done this before, right? You launched radiosondes? So tell me about it.
I've had radiosondes that came almost back to the Weather Service. Like they literally landed like within a couple miles. There was one time where we have University of Louisiana Monroe, and they're directly east of us on I-20, and within a week, 2 radiosondes landed on campus.
How far was that? How far?
Like 3 hours, 3.5 hours driving distance.
Oh, okay.
So
And then how about, so what, do you ever have any radiosondes? Do you know if they ever come back, if they mail them back?
So nationwide, I think it's about 25% get mailed back. A lot of them end up in the ocean or in swamps. So,
wow.
Yeah.
Oh,
so,
okay.
But they can be repurposed. We do repurpose those sometimes as well.
Well, there you go. There's a little bit of information about radiosondes. But you guys take the quiz and look at the radiosondes. But you will have a radiosonde lab. So that'll be posted more than likely Sunday night, because I work at the airport Sunday night, and that's when I get all my work done. Tomorrow, I think I'm cleaning windows. So anyway, so with that in mind, we've talked about the lab. The other thing I wanted to do today, unless you have anything else, is I would like to talk about assignment number 17. Some of you already have done it. Let me just go through and make sure you guys understand what's going on here with assignment number 17. So we'll scroll down here. So what I want you to do on the second page is to, for each of these days, and actually this is back in 2009, we had a blizzard on Christmas here in Grand Forks. Christmas and blizzards, go figure, Grand Forks, right? So what I want you to do is give me the water equivalent, the snow amount in 24-hour snow totals, and then the snow density, and then the snow to liquid ratio. What you have here, these are affectionately known as CF6s. Is anybody familiar with these? Have you ever seen a CF6 before? No, you haven't. So you want me to show you where to find those? Because they're really useful. I'll show you real quick. Well, let's see. Let's go out to the National Weather Service. I'm going to go weather.gov/Fargo Grand Forks FGF. Is that a beer? Caitlin, is that a beer?
It's a Mike's.
Oh, okay. Never mind. So let's see. Here we go. What we're going to do is we're going to go out here. And this is also, I'm trying to kind of show you things that meteorologists use. Go to the climate and past weather, down to local, and it brings up this page. So this is the climate for Grand Forks, and it gives you the daily climate. So there's a daily climate report that goes out. Have you ever seen the daily climate report? I'm sure Caitlin has, and other people have done broadcast meteorology. Dylan, you've seen this before, right? No? Yes, no? Yeah.
So I was muted. Yeah, I think so. Yeah.
Because this is where you get your highs and lows for the day. If you go ahead and click on go, this is the daily highs and lows. This is what you've seen. So it gives you the maximum temperature, the minimum temperature, observed values for yesterday. So our high yesterday was 70. Woohoo! And our low was 32. Was that cold in the morning?
Hey, Fred, you're
Yeah.
on you gotta switch screens. We can't see it.
Oh, I'm sorry. Thank you. Yeah,
Yeah.
shout out if I don't do this. It popped up and it didn't oh, it's showing that it's, oh no, it's not. Okay, here we go. Yep, okay, there we go. Now
There we go.
Okay, great. So this is your climate record for yesterday. It said yesterday's high was 32. Yesterday's low was, no, yesterday's low was 32. Yesterday's high was 70. It gives you the average temperature. It gives you the time that those occurred, record values, 90 degrees in 1992. Woo! And then it's 16 in 1905 was the record. Normal values are 62 and 36, so we were a little bit above yesterday.
METAR doesn't even show in the 30s.
Yes, no, so this was yesterday? What's
so
that?
this morning, it's saying this morning was 32?
Nope, this is yesterday. So yesterday, this is midnight to midnight. So it doesn't
So it went from 32 to 70?
No, yeah, yesterday during the day.
We had a frontal passage, and I only know that because I was forecasting for this for forecasting class. So we knew what happened is the winds were coming from the north, and then later through that day they were supposed to switch from the south, and that's exactly what happened.
Yep. So it really did warm up. It warmed up a lot. This morning, the low was only like 50 something. I was out at the airport this morning and it was pretty warm. I hardly had to wear a jacket, actually. So it gives you, also precipitation totals observed and record values, snowfall observed and record values, and it gives you a summation for the month. So you can see how much, and for the year also, it gives you for the year how much precipitation fell. Gives you heating degree days and cooling degree days, and it gives you other values here also. And that gives you tomorrow's records. So the record for today, which is May 1st, is 89 for a high and a low of 17. And our normal is 63 and 36. And it gives you the years those records were made. And then also it gives you the sunrise and sunset. So if you're looking for some place to find it, that's where you find all this. So this is climatological information. This is your daily climate summary or the climate report. Okay, so that's the daily climate report. if you do the monthly, this is what we call the CF6. Can you see CF6 there? And CF6, I'm going to click on Grand Forks. So Grand Forks is the airport. UNDWFO is the Weather Service office. And then also there's records for Fargo there too. So I'm going to click on Grand Forks Airport, and I'll pick most recent. So most recent would be May. And if I click on that, you only get one day. Let's see, May of 2020. And there it is, one day, I bet you. Let's pull this down. Can you see this? Yep, you still can see it, good. So yeah, it only shows today. No, we don't even have records for today because May 1st is not done yet. So tell you what, let's go back in time. Can somebody help me with that? Come on, you know how to go back in time, right?
I'm not
Yeah, you play Huey Lewis in the News back in time.
Oh, you could do that, or you can go, okay, so back in time. We're going to go back to December, which was a great month. And I'm going to go archive December of 2019. And the reason for that is because I want to show you the blizzard that occurred on the 28th and 29th of the month. And if you look, it gives you all these values. This is for the month. It gives you the daily, the day, the maximum temperature, the minimum temperature. Gives you the average temperature, degree days. It gives you water for that day, the 24-hour water totals, meaning if you melt the snow from the snowfall. This is the recent snowfall. And then also the snow depth. And the snow depth, and no, this is snowfall also. So this is water equivalent, and this is snowfall, but over a 24-hour period. So, and then finally, the 12Z snow depth is the depth of the snow. That's your snow depth. Remember we talked about snow depth? So it shows here, let's see, the blizzard on the 28th, 29th, we had a water equivalent of 0.10 on the 28th and a water equivalent of 0.84 on the 29th. And then the snowfall was 2.3 on the 28th and 9.4 on the 29th. And that's on the snowboard. Those are measured on the snowboard. But the depth, we had, it didn't go up a lot. It shows 10, 10, 13. You had 9 inches of snow and it only added 3 inches. Let me tell you why. Do you want to know why? I was making observations that day. And then everything that fell, it fell on the board and I was able to measure it and then wipe it clean. But then a few hours later, the winds picked up the next morning and blew all the snow away on the ground. So the snow depth was like nothing, but on the board, there was a significant amount. So that's why when you look at these totals, you really have to kind of read between the lines and actually even talk to people that were at that site when they were making those observations. Because sometimes you look at that and go, oh, that's a mistake. And it's not necessarily a mistake. A lot of times it's just wind or other factors that affect the snowfall totals. Not snowfall, but also snow depth. So these are things, when you look at this, things that you have to kind of think about when you're making snowfall measurements and snow depth measurements. I hope that was kind of illustrative and instructive, because making snowfall measurements is black magic. Right, Juliana, you've done this. Have you done this? No, wait a second. In Reno, did they get snow in the summer? No.
No, but I know that one of the times I went to launch a balloon in Bismarck, the meteorologists were arguing because somebody somehow measured more snow on the snowboard when there had been no snow accumulation. And so, yeah, there was a talk about why we shouldn't just magically have another inch of snow on the board.
Yeah. And meteorologists getting over fights over this. Really, they start punching each other about this, and it's ugly. And then pretty soon everybody gets sent home from the weather service, and then there's no weather. So it's terrible. So with that in mind, let's take a look at these. And I'll go to the, so you learned about CF6s, you learned about the daily climate survey. These are things that meteorologists and people that are interested in the weather should know about. You can go back, look at this, you can go back here on this site back to May of 2015 and look up the weather for any particular day. What was the high temperature, low temperature, precipitation? When was that? Oh, when was that in September? That really heavy rain. Do you remember that? What day was that?
I thought that was in October.
Was that October?
Yeah, it wasn't.
Do you mind if I look it up real quick?
I think it was September 20 something.
Let me look. I think it's September. Let me look it up. September 2019, right? Grand Forks, and here we go. Go. Tell me when you see it. That would be water. 3.8. Only 3 point. That was only 3.8 inches. Wow. I
No,
thought,
we had a day of 10 inches.
that's what I thought. Yeah.
I
Was
think
it
that was because I remember, wasn't it associated with the blizzard in October too?
Let me look here. Water.
You could check September 2nd.
I don't see any heavy there. Anyway, so yeah, I was just kind of curious. Go, let's see, September 2nd. No, water was only 0.45 inches.
It was September 21st. September 21st.
Okay,
it's
so
September
yeah,
20th. It went to the 21st. So
okay, yep. So that was about 4.4 inches of precipitation out at the airport. In town, it might have been more. And you can look that up by going here, going to the Grand Forks Weather Service and looking at September and seeing what they had. Let's see, August, I gotta go one more, September, there you go. And they had 4.7 plus another 7, so they had 5.4 inches of precipitation. So there's a little bit more here in town. Okay, so that gives you a place to look for climate information. Now you know where to get climate information, and that's important. So you learned something today. Woohoo! So let's just do one calculation of this, your assignment, okay? Here we go. And then you can calculate it and then get it into me via an attachment and send it in via email. So let's look for this. Where'd I put it? I know I have it open here someplace. Dun, 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 dun. Let's see. Is it here? Creating digital presentations. No, that's not it. Oh, this is it right here. Okay, guys, you ready? Here we go. Let me make this big so you can see it. Whoa, not that big. So we're looking at the 23rd. Let's do the 23rd at the National Weather Service here in Grand Forks. Going here, who's got a calculator? Anybody? Somebody gonna help me calculate? Okay, great, got a calculator. Let's do it here. Okay, so we're looking at the 23rd at the National Weather Service. Here we go, 23rd. So we've got, let's see, 23rd, water equivalent is 0.09. Okay, so take 0.09 and divide it by the snow total, which is 1.6. And what do you get?
0.056.
0.056. So that's your snow density. Snow density is the water divided by the snow. The water depth divided by the snow depth. Okay? And then do you have can you take that number and raise it to the -1? In other words, taking the inverse of this.
17.85.
So your snow to liquid ratio is 17.8 to 1. So that's how you calculate the water. You pull the water off of this the CF6 and the snow also. You calculate the snow density and then take the inverse, and that's your snow to liquid. Does that make sense, kind of? You're going to have to do this on the exam. This is one of the calculations that you'll have to do on the exam. I'll give you days. Now, look at those snow densities. Oh, no, wait a second. You haven't calculated all of them. Does anybody know what the density of ice is?
Where's that thermo equation sheet?
Yeah, yeah. It's 0.91. Pure ice is 0.91, right? Okay. And then what density did you calculate, Caitlin?
For snow density?
Yep.
Right. 0.056.
0.056. That's a lot less than 0.91. So we know the snow is not pure ice. It doesn't have the density of pure ice. Okay, let me ask you this, and I may ask this on the exam. When do you think snow density will be the greatest? In the middle of winter in Grand Forks when it's minus 40 and it's snowing? Or in April, the beginning of April or end of May when it's oh, wait a second. Beginning of April or end of March? When do you, end of March, that's right, March and beginning of April. And the reason is because the snow is more compact, right? It's wetter, it sticks together, you get those big flakes all clumped together. So that means there's more water or more ice in a smaller volume. With pure ice out of the refrigerator, there's lots of ice in a small volume. But with snow, you know, during the winter time, in the middle of winter, our snowflakes tend to be really fluffy and really, really low density. So the density always increases in March, April, May, in the spring, the snow density. And the snow density is always very light in the winter, middle of winter. It's really low snow density. Another thing for meteorologists to think about is when you're forecasting, usually the snow densities tend to be greatest out ahead of a weather system where you have that warm air advection, right? You know, the isentropic lift and all that moisture, you get the big clumps of flakes with a warm front. But after the cold front goes through in the cold air, the ice crystals tend to be really kind of flaky and very low density. And that's what you'll notice when you do your calculations. You'll see that the snow density gets a lot lighter as you get towards the end of the storm. So keep that in mind. So I think you got some takeaways on this. Snow density decreases through a storm. In spring, you'll get higher snow densities, much more wet snow, clumpier snow. And we also talked about CF6s and also radiosondes and where you find them. I think that's enough because I'm afraid that I'm going to give you too much information that your brains will just burst. So, do you have any questions about anything? Life.
I had a radar question for you.
Yeah, okay, shoot the radar. Give me some radar.
So last night, a lot of radars up north, including Fargo's, recorded like ground clutter surrounding the radar, but it was multiple radars. So I was wondering what you think it may be.
Probably, I would think it would be super refraction, right? So, was there a strong inversion last night? Or
I don't think so. I have a screenshot
yeah,
of radar scope.
Yeah.
Do you want me to like share my screen?
Yeah, sure. Share it. Do you want me to? Here, I'll let you share it. Let's see, new share, and oh, wait a second. Share, pause share. How can I share? Oh, wait a second. I need to go to manage participants, Caitlin, more, and make host. So you're
I think if you just stop sharing your screen, I think I could share mine too.
Oh, okay. I'm gonna pause share and then you go. Okay, go ahead.
This will stop on the screen. Okay.
Oh, wow.
And this was on multiple radars all over. Even like Chicago had it.
Yeah. Yeah, I would think it's not clear. I don't think it's clear. Well, I don't know. Let me.
Our METAR said clear, as far as I know.
Yeah, actually, there were some higher clouds. The METARs don't report below 12,000 feet.
Okay, so could this be? Well, I don't think this is high clouds because it kind of disappears.
Yep, it's not
towards
high
the edge
clouds.
of the radar.
No, I'm thinking that's probably some sort of clear air return, but specifically, I think it's gosh, I'll have to take a look at the soundings in the area. I mean, we've got Bismarck and we've got.
It was at Bismarck too, and Fargo and Minot. So
Yeah. Let me take a look at that. Okay.
What about biological?
I don't know.
it could have been birds, honestly, but for that large
no. That's not
yeah.
birds. That is not birds, and that's not bugs, of course. But it's the air density, and I'm thinking it's super refraction. Now let me get back to you on that. I'm pretty sure, but I don't want to say anything for sure definitively until, because I hate to say something wrong and then, oh yeah, Fred said it was that. So let me make sure.
You're good.
Okay. But I think that's super refraction. So yeah. Okay.
So there was a radar. I don't know if you have radar scope or not, but I think Milwaukee's radar last night at that time had birds moving through the area as well as that weird thing.
Yeah, usually with birds you get what we call angels. I don't know if you've ever seen angels, but yeah, but
I don't know.
Yeah, I don't know. Okay. Trace, did you have questions? You want to talk now, or you want to talk privately?
I mean, I can talk now. That doesn't matter. There are a lot of questions.
It's a lot of questions?
Yeah, a lot of very specific questions. So
okay.
It doesn't matter to me.
Yeah, I have another class at 3 o'clock. I didn't realize this is going to go this long. So we can talk about 5 minutes, but that's about it.
Okay, I'll try to be fast.
Okay. Questions? Yeah, if you guys want to sign off, you can, and we can talk or whatever. If you want to listen to the questions, that's fine too. So go ahead and shoot.
Okay, so I looked at in the HailPad lab, and I'm getting a really weird looking graph. I don't know if anyone else got a weird looking graph for the kinetic energy versus the minor axis diameter.
Yep.
That weird spike in it.
Yes.
Okay, so is that one? That's what we're supposed to analyze, right?
Yep.
Okay. And then my second question has to do with what the instructions say.
Yep.
So when it says calculations, it says you want to create a scatter plot with the simulated hailstone diameter on the x-axis and the minor axis diameter on the y. But then when it says to turn in, it has the opposite.
Oh, well then do it the way it says in the instructions and don't worry about the turn in.
Okay.
I'm sorry that I probably screwed up when I was writing that. Yeah.
No, that's okay. I just wanted to make sure that I had them the correct way.
Yeah. I think either way that you do it, you'll get credit because it was confusing.
Okay. And then so the one-to-one relationship, that question, in the lab, is that asking why the slope isn't 1? Okay.
Yep.
Sounds good. I was just, as someone who likes graphs and math, that was confusing.
Oh, yeah.
That means different things in different situations.
Yep. That's good.
Okay. I think those are my questions.
Yeah.
That's what I have written down.
The thing that Donald should have discussed with you, I gave him the key and I gave him all the answers. And the one thing that with the energy graph, some errors, one thing, I went through and calculated myself the density. When I do this lab again next year, I'm going to have you calculate the density of the hailstones. And what you'll find is that the density of the hailstones varies significantly by 2 orders of magnitude. And when that happens, when you calibrate a hail pad, you're supposed to use spheres of the same density. So that's why your kinetic energy is so screwed, is because the terminal velocity depends upon the mass and also the volume. In other words, the density, or the area, actually the area.
Okay,
so that's really going to screw your kinetic energy. So what you have there, I wanted you to plot something up, but that's not what, we wouldn't use these to simulate real hailstones, really.
Okay.
And what they do in lab, you probably, I mean, what they do actually to calibrate is they use steel spheres, and the steel all has the same density.
Okay, that makes sense. I can see how that would alter it. So is it supposed to be a straight line? Is it a linear relationship?
If you have the density, it's supposed to be a straight line, all the same density. Yeah.
Okay, that answers all of my questions.
Great. Good. That was easy.
It was easier than I thought it was going to be.
Okay. Great. Okay. I'll see you later.
Thank you.
Take care, guys. See you on Monday. Bye.
Bye.